Okay, we have topic 1.7, periodic trends. Okay, so we're going to be splitting this up into 3 separate videos, but we're going to start with atomic radius. So atomic radius is defined as the distance between the nuclei of 2 identical atoms. So I drew a little carbon-carbon representation. We'll just say they have one valence shell for simplicity. And this would be the nuclei right here where the carbon are, and then this this highlighted portion is the atomic radius. So why do we see this trend? Why do we see it increasing as we go down and left on the periodic table? Well, because as you go down the periods of the periodic table, energy levels or electron shells are added. So as we go down from hydrogen to lithium, we get one extra electron shell, and then from lithium to sodium we have another. So from hydrogen to sodium we'll have 2 extra electron shells, and so we're getting farther and farther away from the nucleus. So yeah, essentially we're getting bigger and bigger atoms. So that one's pretty self-explanatory. But then as we go, why does that increase as we go left and not right? Because the effective nuclear charge decreases, which is essentially the positive force that the the atom experiences. So the nucleus isn't pulling as hard on the outermost electrons, and you see the atom increase in size. And so let's look at a little example. So which of the following best helps to account for the fact that the fluoride ion is smaller than the O2 negative ion? So these are going to have essentially the same electron configuration. It'll be 1s2, 2s2, 2p6, right? And we're going to have a full valence shell. So it's not going to be anything with electron density or anything like that because we have the same amount of electrons. So let's look at answer C. Fluoride has more electrons than O2 has. Well, that's not true because they have the same electron configuration, right? So it can't be C. D. Fluoride is more electronegative than the oxygen ion is. Well, they're not essentially electronegative because we have the same electrons. They're full. We don't need to look at electronegativity here. And then fluoride is more polarizable. We're not really looking at polarity because there's no bonds or anything like that, so we don't really need to look at polarity. Why is it doing that? And so we know that the answer choice is going to be B.